Hi, my name's Tom Marks. I talk about code. Welcome to another PlayStation 2 programming livestream. Today we're back doing PlayStation 2 asset loading. We had this problem where I made a game, a little 2D side-scroller. We'll run it on the PlayStation 2 in a second. Runs on a PlayStation 2. Turns out loading files was a bit of a problem. When we're testing, we're loading files over the network, and that was kind of slow. So last stream we got a couple of things done. We packed assets together. That was a really bad tick. I apologize profusely. We put assets together into a WAD file. This is kind of like a Doom WAD file, but a little bit different. We can read files from our WAD index, right? So what does this look like? Let's have a quick look. Let's do a quick recap. I fixed the problems off stream, and they were very funny, but not particularly interesting in the world of PlayStation 2 programming. So we have this thing, it writes a bunch of files into a WAD structure. We wrote it in C because all our structures are defined in C, so we may as well stick in C. That's good. And so we use it like this. We say source pack WAD. We give it a couple of files we want to pack together. Let's go source. Let's go star.tga, and we'll put that into test.wad. Okay, so we've packed all these files together. Now if we want to read a file back out, we can go source read WAD. And if we just give it the WAD, it gives us the whole index. It reads it all out, which is cool. And if we give it a file name, for example, source tiles.tga, it's going to dump out the entire TGA into standard out, which isn't very useful. So what if instead we do a diff to verify that this actually works? Let's say diff source tiles.tga, and then let's diff that with this. And the return code is 0. There's no error here. Echo return 0, so that means it worked. It still printed some other stuff out to standard error, but the actual diff worked. Bobbius, good morning, welcome, how are you? It probably actually is morning for you because it's not morning for me. I don't know why I said good morning. Just a habit, just a force of habit. Okay, awesome. So, also I'm using a different keyboard today. The number keys on my main keyboard, my Plink, stopped working properly. Well, my layer keys, so I couldn't do numbers. So I'm using my, what is it? MaxFit. What's it called? Fantech MaxFit or something. Some random Chinese brand. It's a pretty good keyboard. Pretty good keyboard. Okay, so we can pack files, we can unpack files. Oh no, Bobby, it's 7 a.m. but you're still awake. That's the worst kind of good morning. I'm sorry to hear. My condolences. We can pack files, we can unpack files, and we should probably commit this at this point. So let's add a make and unpack test files. Or I guess this is a real binary we'll use to pack real PlayStation 2 data, but this one's just for testing on our end. And then we also want to add source wad. Cool, let's commit that. Let's also add the make file, I guess. And we'll call this add wad pack unpack util. And in adding this util, we had to define the library as well, though. So that is good. Beautiful. What's our git status now? We're fine. We're fine. So now let's do this on the PlayStation 2. Okay, so let's go into main.c. Where I think it's mainly TGA code, right? Now, I think we're going to have a problem in our TGA code in that we actually call fopen from in here. So now when we say TGA from file, we probably want to take in a WAD and a file name. Possibly. Preferably. Maybe? Or I guess we could do something else. Let's do it... I don't want to have to pass a WAD file everywhere, right? That kind of sucks. So one thing I could do would be to make source io.c, and then I could have my own like int, or I could say file. Maybe I don't want it to be a file. I would say like, let's imagine an API for working with files. Would have size t, io get file size. And we would take a const char. God, typing on this thing is weird after doing ortholinear for so long. File name. And this would return some kind of size. This is actually missing from our WAD. We probably want this in here as well, right? We want WAD read file. We also want size t WAD file size. Oh my gosh, I really can't type. My apologies. This is going to be a painful stream in this regard. Your QOI format decoder almost works. I can't remember what QOI is. Ah. Wonderful. This is trippy as fuck. I love it. You should publish this. This is probably better than what you're actually trying to build, but by accident. Sorry, that was a bit brutal, but yeah, there we are. There we go. WAD. Whoa. God, my keys are in different places. What is going on? I hit caps lock. I don't think I'm used to having a caps lock. Let's just do this WAD file size, because that's going to be really important. We don't always want to blindly give a buffer first. We want to be able to allocate the right size buffer. Sometimes we care about being exact. So WAD file size is going to be a lot like WAD read file. We're going to have the same opening, except all we do here, we get the index, and then we return index size. The size of the entry with this hash. Beautiful, beautiful. Okay, so that's really important. And wad.h we have to save because we added a new function. Now we're going to look at io.c. And again, so imagine we have some static struct wad wad. Right, we have some global WAD state. We only have one. Or we have a main one that we load from, and if we do anything else, we have to be explicit. I think that's a good way to work. I think that's a good way to work. So then all we do is return WAD file size WAD, and we give it the WAD hash. Did I call this WAD hash name? And I called this WAD file size, right? Yeah, WAD file name. Beautiful. And then we're also going to say size tio read file, which is just going to be this API, but, oh my gosh, but without the WAD. And it takes an actual file name instead, const car file name. So the reason I'm wrapping this up might look a little bit mysterious, right? But in the context of a bigger program with a more complicated data flow than just a simple tool that opens, reads, and then writes, wrapping this up with a simpler API where we're going to have some global state, it's going to be simpler. It's going to be simpler because everything's reading and writing from one blob, unless it doesn't. But if it doesn't, for example, if one level needs to open a different WAD and read from it, it can do that and it can own that WAD. But if the whole program has to own, you know, the one main blob that it reads everything from, we don't want to have to pass that everywhere. That would be a bit stupid. QI is a simple image format that's really relatively competitive with PNG while being lossless. That's really cool. Maybe I should look at that for PS2 stuff. Because PNG is really heavy. Huh. Yeah, I don't like how heavy PNG is, so maybe I can hack together something small for a different image format. That would be nice. That would be really nice. Cool. You've inspired me. You've inspired me. Maybe I should do a QOI stream, and I'll do it in raw C because that's PS2. That's what we do. Cool. Bit bigger, but not by much. Honestly, like, final binary size, I would rather have a smaller final binary, right? I would rather not pull in a full PNG decoder, but also maybe I should. Maybe that would make more sense. It would be fun to write my own, that's the only thing. Okay, so all we do here is, similar to this, we return WAD read file, and we give it all the same parameters. We just also additionally pass in WAD, and we do WAD hash name file name. Cool. The idea is that eventually maybe we'll have some kind of, maybe there'll be different IO providers, you know, just thinking really big picture for like opening things and reading things, but for now it's all just going to be this one WAD. And this might have to change in the future anyway, because the WAD relies on having a file, like a C API file, but we might have to do it in a more raw way if we want to do proper disk block reads, if we want this on a disk one day. Sometimes pointless abstraction is good, actually. I'm really sorry for my typing. I'm not used to using a non-ortholinear keyboard, but we're going to deal with this today. We're going to survive. Cool, and we'll just say int io init wad path. And this is going to call, we're going to say wad open, we pass in our wad, we pass in the wad path, and let's just return the status code straight through from this. It's a straight pass through. Cool, this is the thinnest wrapper ever. But this global state is worthwhile. I think it's worthwhile. I think it's going to make life better. And you might be like, well, but these functions, like, they live in the same directory. This abstraction doesn't add much. But at some point, I think this wad concept is going to move to the library, but this IO file is going to be part of our application, right? There's a bit of a distinction here. In my mind, they kind of have different colors. They kind of have different textures. One's application code, the other is library code. Cool. Cool. And we're going to have to call this differently depending on where we want to load data from, which might depend on where we're running. So we might have to, hopefully, be able to detect if we're running in PS2 Link, or from a USB, or from a disk, or do 3 different builds, but that kind of sucks. So, I don't know. If and def source IOH define and if. Beautiful. Okay, so let's go into main. Let's include io.h, which is intern. This doesn't actually, there's no tie to wad here, so in io.c we need to include io.h, even though we probably don't need it, and wad.h. This is where the wad stuff comes from. And we need that because we need to know how big this struct actually needs to be. No magic, no magic. Cool, okay, excellent, love it, main. So, we do this, let's somewhere in here, after we've set up the screen and stuff, before we set up the game context, let's do io init wad, sorry. I forget what my own functions are called. io init wad. And this is going to be host assets.wad. Let's do that path. Let's put it in here. And we'll say if this, then something's gone wrong. Logger failed to load assets. This log has more context than our other log. So we say load assets, we p2g fatal, no assets to work with, and we return 1. But p2g fatal probably hangs forever. This is kind of like maybe a no return, we're not really sure. But I kind of miss this. Images 544 in PNG, almost 700 in QOI. Yeah, I mean, rounding up, rounding down, 500, 700. That's an acceptable difference, but that is a few bytes. Like, if you're really scrounging for kilobytes, then yeah, I guess it's not the right algorithm for you. I think on the PS2, simplicity is going to trump everything. I'm using TGA at the moment, which is really really dense. So yeah, maybe that's fine. Also, let's get rid of this line. We don't need to pad VRAM anymore. That was an artifact of me not setting up my Z buffer properly. Not allocating enough space for it. Not understanding video modes. Okay, player index. This is a bit jank as well. We probably need to do something about that. Cool, init load level. Excellent. So now, everywhere we have a TGA. Instead of fopen, we're gonna say, yeah, this is good. We're gonna say, file, when do we read the file? We do an fread here, so, and where do we read it into? We read it into the out header, out TGA data. Okay, that's fine. We do an fread here as well. Didn't think of this. We have to put the entire file into memory to parse it. Maybe... I mean, maybe there's a missing layer here, which is a WAD stream where we can like read and write from a certain offset in the that's a bit gross, isn't it? Okay, so the point is, when we load a TGA file, we do it in 2 steps, right? In step one, let's get a better color for that. In step 1, we read header so that we know how many pixels to allocate. And then in step 2, we use this to alloc the correct sized buffer, right? So if our image is, 64 by 64, we only know how many bytes we need for our buffer to load the pixel data into after we've read the header. Currently, my WAD API only reads the entire file, so we could read the entire file into memory and then parse the header and then like have a temporary buffer somewhere for that. That would work. What would be smarter is if instead of saying WAD. So I'm already changing my API, right? Instead of saying read file, instead of saying WAD read file, what if we could say WAD read file part? Maybe that would be enough, where we could give it an offset and a size. And I guess these would be kind of like, one would be a subset of the other. Let's do that. Read file part. Read file, let's do read file head and read file tail. No, let's just call it part. Read file part. One of these is gonna want to read from the start to a point, and one of these is gonna want to read from a point to the end. But I guess we can kind of hack that in with like zeros or something. Read file part. So this is the same API, except we also say size t file start and size t file end. And if end is 0, that means read until the end. That's how we're going to do it. So now, read file part, read file is just going to call read file part with 0, 0 as the arguments. That's going to be easy. So read file part is the new thing with an actual implementation. So this is just going to steal the implementation from here. We're just going to have to recalculate the numbers. Perfect. So in other words, index.size greater than. So if size t, so we'll say if file end equals 0, then we'll say file end equals index size. Right? If we haven't provided an endpoint, just read everything. Now we want to say size t read size. Sorry for the accidental capitals, I can't type. It's very stressful. Don't know how to type. Okay. Read size is file end minus file start, which is just going to be the size if they're both 0, and that's perfect. So now if read size is too big, and instead of index size we do read size, this is an API that will actually let us just read the header, which is beautiful. That's what we want. So we fseek to now, instead of fseeking to here, we fseek to here plus file start, and we read size. Cool. And actually, we can swap these back now that I remember how this works. We can actually just compare this to 1. And then we would just return read size. 1. Beautiful, beautiful. Now read file, we just call that function, but with both everything as zeros. Return WAD read file part w file name hash target buffer size 0, 0. Awesome. Okay, I think we've done a good thing here. I think we've done a really good thing here. So now if we look at tga.c, we can actually replace this. We can say t bytes red equals io. Oh yeah, I need to do that, reflect that in io.h as well. We'll say read file, we'll say io read file part, and that'll have the two size t args. Similarly here, we're gonna just call the underlying WAD functions still, even though, you know, we could call io read file here, but we're not gonna. We're gonna let this properly cool down. I think that makes a lot of sense. So we're gonna have start, and we're gonna have size t end. Beautiful. Okay, this is good, this is good. So now we have tga.c, io read file part. We're gonna read our file name, and we're gonna put it in, so target buffer out header size of struct tga header, and that's it, read file, target buffer size. No, except it's part, because we need to only read size of struct tga header. My mistake. Okay, there we go. So we read from the start to this point. Then when we get down here, we replace this read bytes red equals io read file part file name out pixels. The size of that is size, and we read from size of struct tga header to the end. Excellent. And that should be the same thing. This is kind of good because in a sense we've calculated the size in two different ways. So if what we read here doesn't match here, we've got a problem. We've got a TGA that isn't what we think it is. And that's bad. Then we have to swizzle it around, so that's okay. So this is now gone. That's one less thing that can fail. So not having to do file IO in this function, that actually feels pretty awesome. Is there anywhere else? grep RNI. Actually, I can do this in Vim. What am I doing? I always forget I can do Vim grep. No, I'm using rip grep still, but I can do it from within Vim. Let's look for fopen in source star. Let's just do it in dot. wad.c, perfect. Okay, the only places we do it are in wad code, which is what we want. Now let's make c source. And we've got some errors, and that's okay. Different signedness. That's okay. That is okay. That's annoying, but that's okay. We can ignore that. Bin make wad. I don't give a shit. I probably should. Hold on. Export platform equals ps2. And then we'll just clean because I think that wasn't ideal. Okay, here we go. Implicit declaration of function io read file part. That's because in tga.c we didn't include io.h. io.h doesn't exist because we put it in the wrong directory. We're going to move that into the source directory. That sounds like a good idea. Okay, so tga file undeclared. That's because file doesn't exist anymore. We just don't pass that magical variable. So this is a good example of using the quick fix list in Vim. This is where it really starts to shine. Name undeclared here, 62, that's the same error. Passing argument 3. Yep, okay, so this is all a kick on from that. Bytes, red, name. Hold on, name? Name. File name. My gosh. Oh yeah, and that makes sense actually, because that is kind of different. That is kind of different. Size T doesn't exist. That's because we need to include stdlib.h, I think. What else have we got? File f unknown type. That's because we need stdio.h. Funny that that crashed when I tried to build for the PlayStation 2, but not everything else. Why do you hear a heartbeat? Is that my typing? It's weird. Heartbeat? Huh. Huh. Weird. Weird. Increases as I type. Well, I am using a different keyboard today, so it is a bit of a louder keyboard, I think. That is okay. Passing different signedness. That's going to get really annoying. Warning. Error. Too many arguments to WAD read file. Yes. Yes. Okay, so... let's just do this. Unsigned car. I hate it, but let's just do this. No, look, it's probably not just you. I'll see. YouTube comments are the ultimate test, because if something annoys people in a YouTube comment, oh boy, do they tell you about it. Okay, so... what open? Const file name. Oh, I got my args backwards. That's weird. I don't know why I did the args that way, but this is now... we're going to live with this forever now. Let's do this. Unsigned car. Just because otherwise this is going to shit me to tears forever. Too many arguments to WAD read file. Part. Okay, there we go. So, LD error. Multiple declaration of main. Well, yeah, okay, so... in my make file, I need to not find these. How do I omit anything in the... look, here's what I'm going to do for now, okay? I'm just going to put this in tools. I'm just going to put it somewhere else. And that's not going to work, but I'll do it for now. And that worked. That just worked. So let's run it in PCSX. Make C source. Run. I'm gonna have to unplug my PlayStation 3 if I want this to work. Anyway, file not found. That is good, because for one thing, we don't have a file called assets.wat. Okay, I'm gonna go to the bathroom, then we're gonna fix this, then we're gonna get stuff loading, and it's gonna be great. Back in 1 second. Okay, cool. Excellent. So this broke, and this broke because we didn't build the file that we need to build. That's going to actually have all the assets in it. So now we're going to hit this problem where I just moved the tools into a folder called tools. Oh, excuse me. So let's just clean this up real quick. Source. Actually, let's just move the pre-built ones, because that's going to work for now. Let's just move them into tools. So we can go tools, packwad, source. Now, I don't want the path to have source in it. So this is... this is where it would be great to have like a strip command line argument, right? Where I could say strip source, and then I could say source star.tga. Except I probably shouldn't have them in source anymore. Let's move all of our TGAs into the assets folder, which is where they really belong. Okay? And let's get rid of makewad.py. Get that out of here. Bah. Okay, so let's go into assets and let's grab all the TGAs. Let's go /tools packwad star.tga, and let's put it into assets.wad, which I think is what I called the thing. I think that's what I called the thing. Assets.wad. That is indeed what I called the thing. Okay. Excellent. Now, it's kind of hard. Like, I want to shuffle this around. Let's just copy it for now from assets.wad into source. Now if I make C source run, it should hopefully be able to find the thing. Hopefully. Okay, we still struggle to open the file. That's cool. Assets, load assets, no assets to work with. So that was because it fails to open the thing. And that's okay, So it looks like it's this thing, right? It looks like it's this thing where it's trying to open it from like my root directory as opposed to a relative one. That's kind of weird. It's kind of very weird. So what if I go, how did I do paths? How did I, for example, in level load, host, just like that? And I think that's what I did here. Yeah, so I don't know why the paths are being weird again. Assets.wad. I wish it was not putting that slash there, because I'm not putting that slash there, right? That is coming from somewhere else, and that makes me nervous. That makes me very nervous. Cool. Excellent. Okay, so we can't find a host. But this is the same way that I'm doing it already. Test load, host, colon. So let's go into the source directory and let's run it ourselves. pwd game.elf. Okay? I think this is how we were doing it. Weird. It can't find the file. Is the file definitely in there? Oh. Is the file definitely in there? Assets.wad. It is. So how did this happen? Why can't it find the file? Why is it putting this mysterious slash into the name? If I do something like this, this doesn't work. Well, I mean, this doesn't work for a number of reasons. Partly, because I don't think I'm in the right place. Run. Host. Okay, I mean, this opens it with a full path, and it fails to load it. It like FD -1. Bad file descriptor. What is going on? What if I do like io.c? What if I do a file that's in that directory? Yeah, okay, so I can read it. So what's wrong with this file? Because this file's here, assets.wad. assets.wad. Let's check the permissions. Assets.wad, rwl, io.c, rwr, sorry. Those are the same permissions. rwrr. So it can read it. Why can't it? I own it. PCSX2, what are you doing? Please. Okay. Make run. Let's just repeat the same thing again. Why does it blow up on me? Why are you doing this, PCSX2? Why have I forsaken you, PCSX2? Again, I'm gonna io.c and see what happens. And it works. What the hell? It can read this file, but as soon as I change it to assets.wad, it like looks for a different path. Huh? This is so baffling. Why does it put this slash there? It doesn't do that when it's called something else. What if I do io.wad? Is it because it's a .wad? Does .wad have some special rule? What? Why does that get further? I'm so confused. It opens this as a WAD and it succeeds somehow, even though there's no file with this name. Okay, I'm gonna do something weird. Move source assets.wad. I'm just gonna call it assets. Okay. Maybe it's the name assets. What if I just called it Z? What if I just called it the letter Z? Like, why is this a different error? Okay, we're just calling it Z. We're gonna see what happens. Okay, this is actually a different error because it's successfully... The not found error is different. Am I failing instead of succeeding again? Am I doing something like this? WAD open. So it's this error, right? It's open WAD. This is what's coming out. Open. Fatal. No assets to work with. Wait, return 1. Oh. Okay, I let a misleadingly high file descriptor deceive me. That was actually fine the whole time. That's really funny. I was like, why does it look like it fails for files that don't exist? And I'm like, hold on. Have I done this again? It's happening again. Cool. Well, that's better. Okay, but now we have to go into our levels, and everywhere we had our levels, everywhere we had host, we just want to get rid of that. Test add, test load, and test entry. Okay, now I think we're fine. Now I think we're good. Target too small. Ugh, I don't like that. I should probably get rid of these test index calls. Target too small. Failed to load tiles.tga. Target index too small. Target too small. How much too small? 32794, 32768. So we're off by just too much. Now, it occurs to me that TGA files have a footer, so actually reading the rest of the file is not what we want to do. What we want to do is give this a bound, and give this a bound of size plus size of TGA struct TGA header. There we go. Now it'll be the correct size. Now it'll be good. Okay, and we're running. Let's skip straight to hardware verification. Let's miss a crucial step and just see how this looks on a real PlayStation 2. So let's go to ulaunch elf. Here we go. Here we go. I'm watching this on my actual stream preview rather than swapping my monitor over because it's kind of easier. But all we do, I've just got a rule here saying run PS2. Let's have a look at it quickly on my main screen. All I do is make run PS2. It calls a program called PS2 client, which gives it game.elf. And then if we come back to the PS2, we have life. We have got life. It's working. So what happens when we hit the fatal loading point here? This is where we were crashing before. Oh, no, okay, that was almost seamless, but it looks like we have indeed crashed again. So we can deal with this. We can deal with this. This is weird because it doesn't crash. But PCSX2 is a bit more lenient with this stuff. So I believe EPC is the program counter. Also, is that shaking for anyone else? Is that just like jiggling by a pixel? Some like weird interlaced nonsense going on there. I wonder if that's a mode on my PS2 HDMI capture. It's bouncing. Cool. Well, that's fun. But basically, bad vadder means we have a bad virtual address. So we're trying to dereference an address, and it blew up, and that's bad. That makes us really unhappy. That makes us go, that makes us feel sad. Cool. Okay. So. How do we catch this? Well, so one thing we can do, we have a tool over in PS2 SDK land, PS2 dev land, MIPS64, this adder to line. And this will take an address and give us back the line number in our code that it came from. Okay, so adder to line. File, no. So what do we give this? How do we use this? Let's just try going. What's the core? What's the EPC? 10898B. Am I reading that correctly? 10898B. How do I set the, set the input file, -E. Adders, okay. 10898B. It says that comes from draw2D. Uh-oh. It says that comes from, hold on, let me swap back. It says that comes from my library code, draw2d.c. So that, let's open a new buffer for that. Let's open a new terminal for that. Oops, not that one. Hold on, that's too many terminals. Where are we? B? Hello? Can you please anchor to something? Not that. Hold on, what's my... There we go. I just blanked on my shortcuts. That was weird. I'm using a different keyboard, so everything just feels different. P2G. Okay, so that is draw2d.c207. It says it came from here, which may not be correct. Is this hex? Do I need to convert that from hex? Does it understand hex? It probably understands hex, right? Is that right? Where would anything... I mean, look, it's in upload texture, and this is probably the most likely function to fuck something up like that. So I'm not ruling it out. Maybe I need to do some more trace logging. But again, trace logging is gonna be tricky. I guess we just run it in PCSX2, right? We accept that the hardware needs a bit more time to cook, reset PS2. This is gonna take us back to the main screen, so we're ready to run another binary, which is cool. Okay, so my error line was not useful. Not particularly. That's okay. We can fix this. Can God, I've got like a million little moths inside today. They're not pantry moths, which is good. I've had pantry moths before, not here. But you know when there's just like more than 3 of a bug inside and you're like, is there a reason for this? Have I been chosen? Have I been blessed by some cruel bug god? Okay, how do I do this? How do I do this? I guess I'll just build for trace logging for now, and that'll be a start. So we change the default log level to trace. I wish I could do this with a command line argument, but I can't. Add it to line only accepts addresses in hex. Thank you, that's very useful. Sadly, we don't get a full stack trace, obviously, because it's a shitty exception handler. It can't do a full unwind. In theory, I guess I could implement that myself. Also, in theory, I could get console output from PS2 client, but it never seems to work, which is unfortunate. I should probably put this somewhere. Hold on. Let's tee it to game.log. And that doesn't work either. I need to map standard error 2 to 1. Okay, there we go. Does that work? No? That does work. I don't even know if I need to remap it like that. I think I can just tee it. Cool, so we have a couple of frames here. Now, that's not particularly useful because we're not hitting the point where it blows up. We only die when we hit a certain point, and we don't actually die on hardware every time we hit that point. Huh. That's a bit tricky, isn't it? Okay, here's another thought just quickly. So let's go to the level in the middle, right? The thing that actually does the loading. Where when we update, we say if the player is bigger than here, we load a level, okay? So what happens when we load test load. So when we init, we allocate this, that's good, load textures, and we check the return value of our TGA loader, so that's good. And it's different to some of the other breakpoint in PCSX2 at that address. That's not a bad idea, and then at least we'll see. The problem is that's going to get called every frame, so it's hard to pinpoint the exact moment. The other thing we can do, and this is really dumb, okay, but the other thing we can do, I guess, is put this back to debug, but when we start loading this level, the first thing we do is say log level trace. I was right the first time. And will this work? Yeah, that's fine. Okay, let's do that. Let's do that. So then we'll only do trace logging once we hit the point with the problem. Cool. Okay. So we're going to move along. We're happy in our own little world, in our own little bubble, and then we're going to hit this point and the trace logging kicks in. And that is what we want to see. Beautiful. Sweet trace logging. I just need to rearrange my plugs. So now we're at a point where that breakpoint might be more useful. We're going to have a better sense of what we're looking for. Oops. Game.log. Okay, so upload texture. So this is where we start tracing. real, it hits all at once. Level bump allocator 17, and so the address was like 7F something, right? It was a big address. It was much bigger than this. It was using all the bits. It was touching all the bits. The highest, not the highest bit, the second highest bit of our 32-bit address, right? Big number for an address. Okay. So frame start, clear buffer, blah, blah, blah. It would be great to be able to run this and get these logs from the PlayStation 2 as well. That's the dream. That's the dream. And PS2 client supports that. That's the really frustrating thing. I don't know why I can't get it. I just get nothing. I just get nothing back from the PS2. I have in the past. Actually, let me try one thing, and let's try running this on hardware. I have a theory. Don't tell anyone I'm doing this. It's a very strange off-camera trick for jumping through network hoops. Okay, let's go back. Run PS2. And let's see. Oh my gosh, it's logging. Okay, so that, I can't believe that worked. And we wanna T this as well. T ps2.log. That's insane. I just did, hold on. I'm trying to run again. I need to reset PS2 first. Let's jump over while I try and reset this. Oh, okay. So that just died straight away that time, which is strange. Now that I've established I can do logging, let's just watch this PS2 screen for a bit. I don't know why that would blow up like that. It's a bit weird. Okay, so this is good. Oh, being able to see these logs is a game changer. This has been the biggest pain in my ass. Cool. Oh wait, that's the wrong controller. So is it... Wait, maybe this is time-based and not even related to this. Oh no, there we go, trace logging, trace logging. We're going. Oh my god, there's so much logging. There's so much logging going on. We're just gonna let this go for a minute. Gathering a lot of valuable data. The address was 7FBFFE5D. It's hard because the line didn't exactly line up to where I thought it should. Right? It was close, it was an indicator, but it didn't exactly line up. Oh my god, we're trace logging so many things. Let me kill it. Let me mercy kill it there. And let me try again. Let me just try this a few times because it doesn't always crash. Let me just try again. We'll have two sets of logs we can look at, but annoyingly did not crash. And maybe it's a timing thing. Maybe if we slow it down, it won't crash for some reason. That would be fun. That would be funny. We can't log the crash. Impossible. Okay, so this is the loading point. This time we're just kind of stuck. No, there we go. There's our trace logging. Still takes a long time to load the next image, sadly. Okay, so let me show you what I see on my screen here. This is everything. So that's really handy. I wonder why. I basically just had to open myself up to all ports on my local network to get this output, which is strange. Very unusual behavior. Don't recommend it. It's fine. I mean, like, I've got other security before my computer, but it's just weird that some port... I don't know what port it's trying to use. I think I've gone down this rabbit hole before. I think that's how I fixed it previously. Okay, so that didn't crash. Frustratingly, that did not actually crash. Let's get rid of that for a sec. I assume my PS2 is probably still... Yep, okay, we're ready to go. Let's do this again. But try... That's the wrong controller. I want this controller. Let's try. Let's see if we can cause the crash. It would be good if we could crash. I want to crash right now. And I have two things I want to test. One is getting over here. And we hit the stopping point, and that's okay. This is the load point. We're loading in other stuff, and that was a lot quicker than it was before I did the WAD stuff. Now, it still kind of stops the world, and that sucks. But, at least we can do something. Cool. So, being able to do file IO in the background, that's probably a good idea. For some reason, we just didn't crash that time. Why didn't we crash? I don't know. Maybe it's a PS2 client bug. It probably isn't. It means we've got some weird memory stuff somewhere. Yeah, unfortunately, I can't move left because my controller handling is bugged. But yeah, it's cool. It's cool being able to verify it. And again, thank you to Stranger, who donated very generously to get me over my donation goal for this capture card. So that's cool. That's really cool. It still looks a bit jank, but that's because I'm on composite cables, not even component. And I kind of love that. I love that it looks like a jank old PS2 thing. Cool. Sorry, I just have to do a manual reset there. Excellent, excellent. So, Whoa, Jack Skelly. Subscribed with Prime. Thank you so much. Welcome to the PlayStation 2 game dev family. Thank you so much for the subscription. I really appreciate it. You know, you could have used that subscription on a lot of different channels. You chose to use it on me. Means a lot. Means a lot. We still have a crash bug, and that's a bit of a problem, but I think we can kind of ignore it for now. So when we load the level, right, the problem is we're loading this level, test edge. We do this here. We do this in our update. So what we ideally need to do is to kick this off to another thread to do in the background. That'd be useful, but also a bit dicey. At some point, we're going to have to do some kind of locking so that we're not fucking with one level while it's being loaded into. And we can do that, but it's just a little bit scary. It's a little bit suspicious, but that's okay. That's okay. We can actually do that. We can actually do that. Okay, that's good. So for now, we're just going to accept that when we load things, we go a little slow. And I wonder where the actual slowdown is. Like, it's got to be loading the TGA, but I don't know why it would take that long. Anyway. We can think about that more later. Cool. Oh my gosh. Alison Franca subscribed. Thank you so much. Thank you so much. I love it. I love it. Welcome to PlayStation 2 development hell. This is where we are. Things crash sometimes and I don't know why, but that's okay. I mean, technically speaking, right? Technically speaking, we did in fact load a WAD on a real PS2, so we can check something off our list. And now I just want to load actual levels like tile maps and stuff from a real file. And that'd be kind of cool, because doing it all doing it all in code, it sucks. It's a really bad idea. Don't do that. It's a really bad idea. So we have a couple of options for loading from a file, right? One is to use tiled, and we could investigate that right now. Some kind of editor where we put tiles down and then we save them into, tiles and entities and stuff. We put them into something dot, I guess, let's say level dot JSON, and then we process it into X. Let's still call it level .ps2, something ready to be loaded in the PS2, and then this goes on to the actual console at some point, right? That's better. That's a little too narrow. That's the vague plan. I don't know, I can't do art. Perspective is hard. Okay, cool. A gift for a fellow PS2 enthusiast. Thank you so much. I really appreciate that. We're still in early days. There's still a lot of work to do to get this going well. So I guess something we could start to tackle today is the format of this actual file. Like, the tiled part isn't as interesting, and the mapping between them isn't as interesting, but establishing a good file format for how we load, what we currently do literally with code, that would be nice. Currently, a level is just a C file. So it'd be nice to have a type of level, a C file, and it did this, but it did this by reading a file. And that file could come from our WAD. That would be great. That would be great. Beautiful. Okay, so let's think about what we would need in a level. Okay, what would we need in a level? We would need a tile map, at least one. N tile maps. Where a tile map is a few different things, right? So what do we need to define a tile map? Let's draw a better arrow. A tile map has a width and a height. It has a offset x, y. It has a collision flag, I guess, because a collision tile map is different than a decorative tile map. So solid. Maybe we'll call this kind, or the type. I like kind better because type can sometimes be a reserved word. So is it solid, which I guess is kind of like what type it is. And then there needs to be some kind of asset ref. You know, what asset does this actually need to be drawn? Where does this tile set come from? What needs to be loaded in memory and resident in VRAM for it to draw? And then the actual tile data, which is an array of W by H, right? Something like this. So we'd have n of these, and that's all we really need for now, but then I guess at some point we'd also have like entities. You know, things we need to actually put somewhere. Things we need to put in the world that are interactable. And then maybe, I don't know, that's probably a good start for now, right? So if we had some kind of header, it would say, we would say, let's imagine a header for this file. Let's have a version, which is going to be a U16. Let's have a ID, which is also going to be a U16, but let's swap these around. So something so that we know what kind of file this is. Okay, so that the Unix file utility could tell us, hey, this is a PlayStation 2 game level. That would be cool. That would be cool. And then we need the number of tile maps. And let's actually use a real number, hash number of tile maps, which is also going to be a U16. Actually, this can be a U8. And number of entities, which can also be a U. Let's also make that a U8. We don't want loads. We don't want loads of entities defined in a chunk. Maybe we do. Let's make it a U16. It can't really hurt, can it? Except for alignment. So I guess this should also be a U16. We'll keep things 16 aligned. Can't hurt. 16. Cool. And then we need the offset of the index of tile maps, because tile maps need an index because they have this tile data that's arbitrary, or our index is kind of like this, and instead of having tile data in place, it has an offset in the file where the tile data lives. There's two options. They're both good and bad for different reasons. Let's do this one. So the header looks like this, and then we have the index. Right, we did indexes with WAD files. We're going to do indexes again. The index is n times this, but tile data is a file offset. Cool. And then we'll have m times entity, which will always be 0 at the moment because we don't know what that means. We don't have any entities in our game yet. Okay, this is a file format. We can do this. And then I guess also a good part of step 0 would be to have a Python script which could take oh, actually, there's something else we're missing here. We'll work that out as we go. A Python script that could take a file that was like 0, 0, 1, 0, 3, 2, you know, that was tile data, maybe a set of these, like a list of lists, and convert that into a dot level. Does that sound good? Or maybe we do a C file again, I don't know. I think Python might be better suited to this, but also maybe not. We'll find out. Let's try it. Let's try it. Let's start doing it and see what happens, because that's how I like to approach everything when I'm developing. I think this is a good candidate. And then once we can generate it from basic stuff, we can try and do it from tiled JSON files as well, and then we'll have better stuff, right? We'll be able to do better stuff with it. But for now, we'll do the janky shit version. We'll focus on this part, right? The lower level of it. And then off camera, I can do this boring mapping and it won't be that exciting, and I'll make some content, hopefully. Something resembling a level, something maybe resembling a game. Maybe. Sounds a bit crazy, I know. Cool. Let's do it. Okay, so I'm still on my WAD branch, right? Yeah, that's good. Oh yeah, I need to source bin, make WAD, git add. Git add tools. Okay, we worked out we moved these, or renamed them, which is good. Now, what's the rest of our diffs? Well, tiles.tga, git add source, tiles, test. I can't use a star, which is annoying. Git add source, tiles, test 1. Okay. Git. We've got to. I've got to clean up what I'm putting in here. This isn't quite right. Raw tiles. Cool. These are just files I'm playing around with. I made my own ugly tile set because I might try and make my own tiles. That might be more interesting. But also, I don't know. I'm bad at art, so that's hard. Let's do this. Let's go git commit. What did I already do? And tools around. What's the diff in here? Oh yeah, so let's git add source wad. This is a fix-up, so we'll just merge this in. Like we'll squash it in because we don't need that to be its own commit. And then what else did we change? All this. So this can probably be one commit, right? Actually, just everything in source, right? Oh no, except git restore staged source no assets.wad, and that probably needs to go in our git ignore. Status assets.wad is gone. Beautiful. Okay, so use IO abstraction. Load everything from a WAD. And then we're going to git add, git ignore. Beautiful. Done. Okay, excellent. This is good. This is a good change. Let's... Do I start with the C headers? I probably do, right? I probably start with the C part of this. The C part of this. By the way, I didn't really ask, but Alison Franke, what kind of PS2 enthusiast are you? Like, what PS2 stuff have you done? Are you a game enthusiast? Are you a PlayStation 2 coding enthusiast? Are you a programmer? How'd you find this stream? What brought you to my shores? Let's just clean up some of this garbage around as well. Let's clean up our ps2.log. It's not that interesting. I like that it's there, but it's not that interesting. Okay, here we go. So let's go source levels format.c. Let's imagine what a level format will look like. Struct level header. Okay, so we'll go ID. Let's just go unsigned car ID. No, hold on. What am I doing? I'm using a different keyboard today. So my typing skills are hindered. Let's make this 4 bytes long, and it'll be some like silly string. Gamer and amateur programmer, you like watching people coding? Awesome. Well, that's really exciting because I do a lot of that. You found the right place, and I hope this is a good intersection of your interests. If you have any questions, feel free to ask. This stuff is, there's a lot going on. There's a lot going on here. So we have a version, we'll have a uint16t, tile map count, and count, just count, not counter, just count. And then we're also going to have a uint16t entity count, level tile map def. Let's call it tile map def count and entity def count. Now, this asset thing is going to be a problem. I didn't think about this. I didn't think about what this would look like, but we'll get back there. Let's go uint16. Oh yeah, we need another thing as well. Let's go uint32t world offset. And that's going to be 2 numbers, an x and a y, for where this level lives in a big smooth scrolling world. Let's make this a uint32t as well. Let's call it. So we have world offset. So this is going to be like local offset, right? If this is our world position, we add this to it for the position of the tile map within the world. It's a bit of a funny thing, and this might always be 0, but maybe we want to offset things sometimes. Things may not always align. So we'll have a uint. I guess we'll make it a uint32t dimension. Size. Let's just call it size. How big are we in each dimension? Let's say enum tile. This is more of a flag, so let's go uint16t tile map kind. It's going to have an asset reference for what needs to be loaded. We'll work out what that means later, but for now it's just going to be a number because this is what's going in the file. And then a uint32t for the map file offset. Where in this file does the map actually live? Beautiful. And then an entity definition is going to have a uint 16t kind, and that's it. It's going to be pretty much empty for now. And we only have 0 entities. Actually, let's not even bother defining something because it's always 0. It's always 0. Cool. So let's start writing a function that's going to actually deal with this structure. Let's say load. Let's say. Yeah, let's maybe say, how do we say this? What's the best way to say it? I guess we want to just load the header first, right? The header and struct level defs, maybe. This is like the first thing we load, which has a struct level header, and then a struct level tile map def. I guess I need to alloc something somewhere. I don't know if here's the right place. I mean, I guess we also just pass an allocator to it and then we don't care. So let's go level load. What are we loading it into? This is an even better point, right? What's our representation of this when it's actually running? What does a loaded level look like? A loaded level is very similar. It has a Maybe we also want some kind of like hard-coded name in there. I don't know. I don't know if that's useful. Actually, yeah, I think that works. I'm just kind of thinking about what tiled will let us do. Let's go car short name. And let's give it a 20 character name, potentially. Let's give it a 24 character name, potentially. That's a nicer computer number. Cool. That's fun. That'll be good. That'll be good. Okay, so a loaded level, it's going to have a car short name. And let's make this an actual thing that we've defined. Name len 24. You've been missing your Sony Trinitron. Where's your Trinitron? I found a Trinitron for sale for $100, and it was maybe 25 kilometers away from me, but I don't have a car. So I can't really be going out to get a 65 centimeter Trinitron and then taking that on the train. I think I might die. I think I might suffer some kind of muscular disorder if I try to carry a Sony Trinitron that far. I don't live near a train station either. Man. Alright, so once the level's loaded, we'll have the name, we'll have the tile map count, and then we'll have the actual, like, tile map, the actual type. So, level, this has, yeah, so let's maybe say struct EE texture textures, which is going to be an array. We're going to have to allocate it. We're going to have a struct, I think it's just a struct tile map, right? Context. Context. That needs to be context.h. Decoration called struct tile map, which is also going to be an array. A CRT enthusiast bodded off you for $10. It's always hard, right? Like CRTs are a pain in the ass. There was someone even further away. They were probably 50 Ks away from me. And they were like, they had a listing, they had 4 CRTs on it, and it was $50 total. And I have no idea if that was $50 each or for all of them. They were desperate, right? They were like, I need these gone. Just come and take them. You know, I don't know if they work. I'm only going to plug them in if you're going to come and get them. We can do it when you're here. But they just sounded busy, like they were stressed. And that's when you want to buy someone's CRT, right? When they're at their most desperate. Man. But it does suck. It sucks you had to get rid of it to move. It's always hard. It's always hard. So, these are the things we need. These are the things that we will actually require when we're doing this. Now, let's make an enum for the kinds of things a tile map could be. Let's have a map collision, and let's have a map. Actually, I thought these were going to be flags. Let's just call this flags. Oh no, look, let's call it kind. We can make it flags if we need it, but I don't think we'll need flags. I don't think things are gonna overlap. Cool. So we'll get a tile map kind out of this. That'll be fine. Is there a way to... No, look, let's not get too lost in that. I just want to make sure... It would be nice to use this type, but I want to make sure C makes it take up a consistent number of bytes. I guess it would be okay, right? Like, I don't know. Anyway, let's not get too lost. Let's make the ID, let's call it LVL2, right? Those are going to be our 4 characters that identify the header, because that's cool. I think that's cool. I think that makes sense. And these maybe don't need to live in this. Maybe they can be in the .c. Well, this is the .c, but this is all going to move to the .h, or a big chunk of it is anyway. Okay, level load. In conclusion, after all that's said and done, because most of this, yeah, cool. Okay, this is good, this is good, this is good. The only thing we don't have, no, I guess we just put all of our EE textures into VRAM every frame. This is good, this is good. Okay, so level load, we're gonna load const car fname. So the first thing we do is just read the header, because this is a fixed size. Struct level header equals, we just make an empty header, we zero initialize it to be sanitary, but it doesn't really matter. IO read file part. So we only read the file fname into header. We read the first size of struct level header bytes. Beautiful. Beautiful. What do you mean, Cricket, by your CIT found its way to a golf range? What does this mean? Do golf ranges famously have a lot of CRTs? Is this a true fact that I don't know? Or is this an untrue fact? I'm very confused. It's very easy to confuse me these days. Not as sharp as I used to be. I did win a Quake tournament game right before I went live. I played Das Bock, hero of Division 5 in Australia, and I beat him pretty convincingly. So that was good. I lost my first tournament game, and then I won my second one. So hopefully I'm going to keep winning from here. Every day I play more again, I get better, and that's fun. Read file. Okay, so we also need to say RC. And we're going to say if RC, if not RC, if we didn't read any bytes, then something's gone really wrong. Log error, load level s fname. And then we want to return 1. I can't remember what, I need to be consistent. I need to define these as macros somewhere, right? What is an error return and what isn't, because I've forgotten. I've done it differently in lots of different files, and that sucks. Okay, so read file part. We read the header, and then we know how many of these to make. So let's go struct. Oh yeah, hold on. I need an allocator as well. My bad. And I think these are just passed in like this. Struct allocator. Cool, we give it an allocator. Level context. Yeah, so most of this stuff is going to be the same for all these levels, but then some of it will depend on what we're doing. That's good. That's a good thing. Also, we need to take a level context to load it into, I guess, right? Maybe let's just get a context. Let's go struct. And the level context has an allocator. Maybe we allocate it into there. Okay, hold on. Struct game context. And we don't pass an allocator because we just get one from the context. That's what we got to do. That's what we got to do. CTX load level init function. Yeah. Excellent. So actually, the level init function, this takes a game context and a level context. So let's say that we can actually go one step further. This has been a real journey, but FMT. What we want to do is give a game context and a struct level CTX a level. There we go. I think my light's about to die. I can see it wavering. He's struggling. He's really struggling. It's been a long day for him. It's been a long day. Okay, this is good. So read file part into a header, and then we want to say level tile map def. We want to alloc this. We want to alloc from. We want to put it in a level allocator. We might as well use our level allocator, right? That's what it's there for. We put it in here, the one thing, and its size of, it's n things. It's header.tilemapDef count things, and its size of struct level tile map def. Beautiful. Okay, good. If not tile map defs, beautiful. Beautiful. God, I didn't realize how annoying it was going to be typing on a different keyboard tonight, but it's slowly driving me insane. Not in a bad way, but you know, I'm noticing. I'm noticing. Okay, so yeah, this is fine. This is fine. I think this is good. I think this is good. I've realized another piece of the puzzle that we're missing, but we'll get there in a second. This is okay. This is okay. Time map defs. Okay, so yes. Now for int I equals 0, I less than header tile map defs I plus plus. So for each of these, actually no, we can read this in one block. We know how many things. So let's go rc as io read file part. And this means we're going to have to look up this index a couple of times. This is where a better index lookup would be smart, but that's okay. That's fine. Let's make a size t read head, which is size of struct level header. Okay, so we start reading at the read head, and we read until header.tile map defs def count times size of struct level tile map def. Beautiful. Then we want to say if not rc excellent. Excellent. Okay, so now we can actually go through these. So for int I equals 0, I less than header.tile map def count I plus plus. Beautiful, beautiful. Beautiful. So we want to allocate the tile maps. We want to deal with the tile maps. Level data, allocate from. How does this work? How does tile map init work? It takes an allocator. Oh yeah, it just puts it in place. That's kind of cute actually. I forgot that was so cute, but I love it. So we need two ints. We need has deco and int has col. Because we kind of have these standard tile maps, and at the moment we're just going to load the first decoration and first collision tile map we find. In the future, we'll do different things. Maybe. Or maybe not. Maybe not. So if, let's go enum tile map kind equals, let's actually also go struct tile level tile map def t is tile map defs I. And we want to take the address of it so we don't copy anything unnecessarily. Okay, now we've got a convenient reference, so we can say t tile map kind. And we just cast it into an enum, because that's okay. Excellent. So if kind is map deco, then if this is the first decoration map we've seen, not has deco, let's make them both equal to 0. I mean, these are bools, but we're just going to do it the old-fashioned C way. I think that's fine. So if it's a decoration map, we don't have a decoration map yet, we go level Sorry for having to bounce around so much. Decoration. Let's go struct. And then we don't have to allocate anything. So let's go target equals the address of this, and has deco equals 1. And then we'll do the same thing for a collision map. We'll get the first one. And if we have extra maps, we can put them in the level, but we'd have to actually allocate them and keep track of them in a way that I'm not really committed to right now. And that's fine. That's fine. Map. And the reason that it's useful for levels to have these defined things, even though they can define more and it's like more work for them, is for debugging purposes. Sometimes it's useful to just say, show the most prominent collision map that this level has associated with itself. And maybe that's a bit of a bad place. Maybe that's not actually a good thing, but I think it's okay. I think it's okay. Cool. Nice. Has col equals 1, has col, has deco. Always good to double check we're using the right variables to track the right state. Beautiful, beautiful. So, now we just want to say tilemap init. Tilemap init. We're going to copy another use of it from somewhere else. Tilemap init. We grab whatever our target is. The width is going to be at def. Now let me double check with tiles.h. This is our width height, yes. Grid size, offset x, offset y. Okay, so width, this is size 0, this is t size 1. The grid size is the grid size, it's always the same. Now our world position is gonna be, and this is good, this is important. So this is our header dot what did I... God, my memory is like a sieve today, isn't it? I think working with a different keyboard hasn't helped. This is a header world offset 0 plus t local offset 0. This is where we are in the x coordinate in the world. And then we do the same thing for a y coordinate. And we have an allocator. Of course we have an allocator. We always have an allocator. Awesome. Awesome. I think this is good. Remember to allocate. Oh, we should also check if not target, then let's just continue, I guess. And then outside of this loop, we say if not has deco or not has col. Then we want to log must have at least 1 collision and 1 decoration map. Like, that's an error. That's just a plain old error. Beautiful. Excellent, excellent. So, collision has collision. This all looks pretty good. This all looks pretty good. The only thing missing is the asset reference, right? The only thing missing is this. So, what does an asset def look like? Let's put it in here. Struct asset def. Okay, this is going to be uint16t. This is going to be an asset kind, and it's going to be a uint32t file offset, an offset within the file for like where the string lives, I guess. Right, how big is the name, and where in the file does it live? It's like a big string table. Lots of files do this, right? Because then you can have all your asset definitions in a row, and then you just have your big blob of data at the end, and it's somewhere in there. I don't know. We'll work it out. Work it out later. It's all fine. That way, in theory, you can also compress your big data blob, but still read your headers quickly. Maybe? Maybe? I don't know. Maybe that's bullshit. That doesn't sound right actually now that I think about it. But I don't know. I feel like there's an advantage separating out your headers and your data, because then you just have this big blob and it doesn't matter what's there, but your headers are really easy to parse. So let's go, and so this just references the nth asset definition. So let's go oh my gosh, I've forgotten how to type on a normal keyboard. I've been using my Plink for too long. Okay, asset def count. So we need to get asset definitions as well. We need to do this as well. So this is a big function. Could probably do with getting broken up, but that's okay. Now let's say struct asset def and we'll do a similar thing. We'll do this little copy paste and then we'll move stuff around. And then this is just called an asset def. Okay, on line 49, we need to put a thing in, because it's a ref, not a value. We don't move an allocator by value, because that's not useful, because then we can't remember what the state of the allocator is after our allocation. That would be silly. Did I just spill water on myself? Oh my gosh. I'm out of control. It's been a long day. It's been a long day. It's going to be a long day tomorrow too. But, my gosh. Separate headers. If you only need to read headers, you do less jumping around. Yeah, exactly. You don't have to, and that's actually the best advantage, I think. You don't have to walk an uncertain structure. You do all your reads in big blocks. Yeah, you're right. You're spot on. Like, you couldn't do this, right? You couldn't just read them in one go like this. I keep hitting caps lock, I'm really sorry. You couldn't do them in one go like this. Oh, and we better move that read head as well. Let's go read head plus equals header dot tile map def count times size of struct level tile map def. Beautiful. Okay. So we read from the read head, and now it's asset def count and size of asset def. Beautiful. We do the similar thing if not RC. Read asset map defs. Beautiful. So now this is a reference to this list, this array right here. And tile map is a bit of a misnomer, I guess, because they're not all tiles. I guess they are tiles. They're just not necessarily tiles you draw to the screen. They could just be tiles that represent collisions. I guess that makes sense. If map deco map collision, so the only other thing we need to do is this t, and let's say if t asset ref is greater than, is not equal to -1. Let's use -1 as our kind of dud placeholder, aka uint16 max. It may even be better to say uint16 max, right? The biggest 16-bit number. This is our dummy. This is what we throw away. This is what we don't care about. Okay, so our ref is this. Our ref is this. So we have a real asset ref, so we say struct asset def. This is asset defs t, except we need to bounds check it first. So if t asset ref is greater than header dot asset def count, and I think I called this asset def count, good. If we've got a bad reference, we should log an error and just die. Map in our file, so map I references t asset ref in fname. Beautiful. And then we should return 1. Okay, so and you know, I think this work is worth doing here because this is all going to come back. We're going to use all of this for like a 3D game. We'll have these kind of concepts as well, right? This file format is going to be pretty flexible. And so this is basically saying, yeah, what stuff needs to be in VRAM when I draw. And that's not going to be the be-all and end-all for 3D, because in 3D we're going to have model data that doesn't live in VRAM. It can't live in VRAM, has to go via the CPU, so there'll be extra stuff, extra steps. But here, we really only care about stuff in VRAM, and that's nice. That makes it nice and simple. Okay, so we've got an asset def. Now we just want to get the name. Let's go car name equals alloc from. We need to put it into a buffer somewhere. So we're going to get this asset name, put it into, and this is a jank way of doing it, but for now we're just going to allocate from the level allocator, and we're just going to take the asset definitions name len. We just need this many bytes. Easy, easy, and then we just read it. We say rc equals we're gonna read file part. Read head, except we don't read from read head, we read from a name file offset name. Naming things is hard. And then our length is just a name len. Beautiful, beautiful, easy, easy. Cool. And if we don't read anything, this is an error. Map asset I. Let's be more hierarchical here. Load level with a name, map d references asset d. Hierarchical errors are good. Fname, and then this is header dot asset def count. Beautiful. Okay, so we're going to read this, load level s, asset I, read name at d, fname, t asset ref. I guess the path of the asset is useful as, oh, but we don't have a name. We don't have a name. So we can't log the asset name. There is no asset name. What we can log is file offset of the name and the name len. Cool. And you know, one map being bad can poison the whole load. It can poison the whole process, right? The whole process can die. Okay, so allocate from read file part. We've got a name now. We've got a name. So we can just do our dumb TGA load from that. So for now, we're just going to assume everything is a TGA, and that sucks. But it's a good place to start. This is all we need to start. So we're going to do this. And let's put this in its own function. Let's call it, and let's let's investigate what we actually need here. So we need a name, const car fname. And let's give it a struct level ctx level, our levels context as well. And what's this loading to? It's not really loading to anything. We should also give it our level loaded, right? Or a struct e texture that we're writing to. So not necessarily the level data, let's say struct. Right, the place where we're putting the fields for this texture. So struct level data. So we don't want this. We want target pixels. We want awesome. We do a VRAM alloc, which is good from our level VRAM allocator, the number of pixels, and we do a divide by 4, which is even better. Why do we divide by 4? Because VRAM addresses are in words, not in bytes, but my VRAM allocator works in bytes. Beautiful. Okay, so this is good. We have our asset now. We have an asset name. We just need to say load TGA with our name, which probably isn't null terminated. Okay, so that's a problem. So we actually want to allocate one more byte than we need so that we can null terminate it. I kind of hate that. And then we'll say name len equals 0, and just really make sure that we've null terminated this. Otherwise things are going to go bad when we try and pass it places. Thanks, C. I love C. Okay, so this is our level, and then we want to, we need to allocate this as well. So do we have our level loaded? Do we have the thing we're actually loading into? No. Let's do that up here too. Let's go, so level loaded, this is actually kind of like our level data, which is funny. So let's allocate it. Let's go struct level loaded equals alloc from level allocator, and we'll do size of struct level loaded. Oh my gosh, this is getting messy. Okay, this is a lot of code to write in one go. This is C. This is the C experience. Okay, so level loaded. So before we can do this, we've got to, for one, we'll just leave this as null for now. That's okay. But the textures we do have to allocate, because for each asset, so once we know the number of assets, when we do this, I guess, we probably should also say, what did I call this? Level loaded. Wait, did I give that a name? No, I didn't. Let's call it loaded. Let's say loaded textures equals, this is another structure we need. This is what we use at runtime. Everything else has kind of been more relevant at parse time. So the point is, right, we've got this structure and we have to turn it into the kind of thing we can deal with when the game's running. We can turn it into things that, from this format, into things that play nice with my existing code. Okay? Oh my gosh, it's after midnight. It's no wonder I'm running out of steam a little on this big refactor. So we're going to alloc from our level allocator, and we're going to allocate header.asset def count times size of struct e texture. Beautiful. Okay, now we're cooking. Now we're cooking, because now we give loaded textures a t asset ref. God, I feel myself crashing. And that's probably a good sign that I should stop, because there's no chance I'm pushing through long enough to also write the Python code to generate this thing to be parsed. So I think I'm probably going to call it there for tonight. I wish I could have started earlier, but I got stuck out of logging into Twitch for a little while, which wasn't great. Didn't love that. So I need to get an early start tomorrow. I've got some places to be. Let's see if we can find a cool stream to throw some love onto. There's a couple of new people hanging out today, I think. So if you have any thoughts on cool people to raid, I'm always happy to hear them. Thank you for the hearts. Thank you, Bobbius. I hope you can get some sleep. You too, Cricket. It's a weird time that you're like, it's like 2 a.m. there, right? You're well into tomorrow or today, I guess. Third-person action combat game, learning game dev from scratch. I only stream because I have no self-control. Bit of Cyrillic. But yeah, I'm glad you guys are enjoying this. I'm glad you guys are enjoying some nitty-gritty file format stuff. I kind of love that the PlayStation 2 is forcing me to do it all. I can't just use Unity or something. And I can't, you know, you might write this file format a little differently if you were parsing it with something other than C. Alison Franca, thank you so much. I'm glad you're enjoying. If you have any recommendations for people we can throw a raid onto, would love to hear them. Japanese arena folk are playing Wolfenstein enemy territory. I would prefer to throw it on to a coding stream. Is that like is that oh my gosh, I'm blanking on his name. What's the Japanese Quake player's name? Ava CCT. Okay, that's not who I thought. Oh yeah, they're playing Wolfenstein. they're playing Wolfenstein in 2024. Yeah, Agikara, that's the one I'm thinking of. He's the Quake guy. Wow, that's kind of cool. This is a little bit too niche. I'm not gonna raid this, but this is cool. Wolfenstein Enemy Territory is a cool game. I'd love to play it sometime. Gosh. Cool. I mean, look, there's Golang CLI tools. That sounds really fun. So let's throw some viewers onto this person. They're a bit bigger than me, but that's okay. Let's throw the love on. Oh wait, no, this is RWX Rob. I know RWX Rob. Let's obviously raid RWX Rob. And there goes my light. Perfect timing. Right at about 2 hours. So thank you everyone for tuning in. Thank you everyone following along on YouTube. I know you're out there. I appreciate you. And it's been a great stream. We've had some good engagement today. Always love to see it. Thank you so much. Let's go share the love with RWX Rob. Bye.